So the question is, who is this distinguished older gentleman I'm chatting with? That's Luc Montagnier. He's the discoverer of the AIDS virus, for which he won the 2008 Nobel Prize. So he was the keynote speaker at the 10th Annual Conference on the Physics, Chemistry, and Biology of Water this last year, held in Varna, Bulgaria. So at this conference, I presented my research. This conference has been held every year at the organization of Gerald Pollack. Gerald Pollack is well known for his discovery of the so-called fourth phase of water. We're all taught in school that water has a liquid, a solid, and a gaseous phase. And Dr. Pollack famously discovered that there's a fourth phase of water, somewhere between liquid and ice, that is more gelatinous-like. And this so-called fourth phase water is a topic of intense investigation, as they believe it has biological relevance. In other words, it's this special biological form of water that actually regulates much of what we think of as cellular activity. In fact, some folks go as far as to say that this fourth phase or gelatinous water is actually mostly what makes up a cell. In other words, there's no discrete cell boundary layer. It's actually more an illusion that water makes up the geometry and the structure of cells. So the question is, well, the question Dr. Montagnier asked me was, first of all, he was complimentary because obviously these experiments showed some pretty unusual results. And we just chatted briefly about frequency and water structuring. Obviously, he's most famous for his discovery of the AIDS virus, but actually some of his more recent work is really mind-boggling. I mean, if you don't know a little bit about water research, it really does look like science fiction. And what he did quite recently was take a DNA sample from the blood of an AIDS patient. They then diluted this many times so that it was essentially like a homeopathic dilution where there was really no detectable remnants of anything left. So essentially it's like purified water. And they took this water, they recorded the signature of this remnant, DNA, we'll call it phantom DNA for lack of a better term. They then digitized this recording and sent it electronically to Italy. So somebody somewhere in France emailed another researcher in Italy the recording of this DNA. I know it sounds odd, but that's what they did. So in Italy, they receive this recording. They then play this recording through a coil to a vial of distilled water. So it's just water, or purified water, we'll call it. And when they added some nucleotides and polymerase to conduct what they call a PCR, or polymerase chain reaction test, they left out the missing key ingredient. And that missing ingredient is, you guessed it, a fragment of DNA. You can't make a photocopy without putting some paper on the copier. But that's exactly what Montagnier did. Imagine you have two copy machines. So you're standing here at copy machine A. You put the paper you want to copy in copy machine B over here on the other side of your office, and then you press copy print. What are you going to get? Nothing. A blank piece of paper. Montagnier did the biological equivalent of that. He hits print, and what comes out? 98% of what was sitting on copy machine B. So with 98% accuracy, they were able to structure, that's right, I said it, structure water using a recording sufficient to substitute a fragment of the actual DNA itself. I mean, it actually created quite the controversy, and that would be an understatement. I mean, there was an uproar. He presented this research at the annual gathering of Nobel laureates in Lindau on Lake Constance, and it went over like a lead balloon, let's put it that way.